going to add into today's lesson, we're going to solve equations using that DCV that we did last time, right? Remember we talked about that DCV, dogs crap violently? So D is for distribute, and that's we distribute with our parentheses. C is for combine like terms, and V is for get the variable on one side. Now, we're going to do that. The new stuff is we have to justify each step. So this word here I'm going to put in a little heart, because if you don't read on the regents, the directions, and I am guilty of this myself, I go right to the problem and I kind of skip all the directions. If you have to, it's kind of like a proof. You have to give reasons why each step is so. Okay, we'll go over that in a second. Then there's two new things we're going to learn today. I think you may have done them last year. But the new things are that sometimes there are something called no solutions. And that's an example is given here, is if you have a number that's not equal to another number. What happens is the letter or the variable disappears. It ends up gone. And the other new thing is that sometimes you'll get a number equal to a number or a letter equal to a letter, and that's called infinitely many solutions. So those are two new things that they throw in there. And the Regents does throw those in there sometimes, and they won't tell you this could be no solution or infinitely many solutions. All right? So the first part is let's justify our answers. So for this section, I'm going to break it down the middle here. On this side is going to be our reasons. Sometimes we call them reasons. Reasons why we can do all the steps. Okay? And then I'm just going to kind of break it here in the middle too. The first one's going to have two reasons. The second one's going to have a little bit more. All right? So if we look at the first one, solving it, the first thing we do to solve this, there's no distributing. There's no combining like terms. So we're just going to get the variable on one side and everything else on the other. So I'm going to add 17 to both sides. I get 3x equals 69. The reason we can do that, and I think you guys did it last year with Miss Shug. I'll write your notes on. The reason we can do that is this. It's called the addition property of equality. That means whatever I do to one side, I do to the other. You've learned that since middle school, right? But now they call it of equality. That's why we have that scale up there. Whatever you do to one side, you do to the other, right? The next one is I'm going to divide both sides by 3. Well, that now is called the division property of equality. On your homework and in the notes, I don't care if you abbreviate, but on a quiz or a test, they want you to write it all out, all those words. And of course, the answer here is going to be 23. Now, it tells you in here, too, to check your work. On tonight's homework, you must show us that you can check. I'll do a couple checks. I won't do all of them, especially the next one I probably won't check. But this one over here, because, again, on the Regents, they make you check. They make you solve, justify. Usually if they solve and justify, they'll add that word check in there. So we're going to plug 23 into the problem. 3 times 23 minus 17 equals 52. And then you would put that in your calculator and you get 52 equals 52, right? Everybody knows how to check, hopefully, right? No? You said no? Someone said, you don't know how to check? Oh, you didn't? Okay, yeah. Oh, okay. So yeah, you just plug it into the problem, put it in your calculator, and that's it. So, if I have the addition property of equality, the division property of equality, I also have subtraction property of equality and multiplication property of equality. Those are the only 4 new things we're learning today. And I don't think they're new because someone in my last class said Ms. Shug did do them last year. Is that right? The of equality properties? No? Okay. Yeah. She did? Okay. All right, so I'm going to make this one bigger because there's a lot more work to the next one. So, all right. Again, if we write our DCV over here, yep, we're going to distribute first, then combine, and then find our variable. So when I distribute, 3 times 2 is 6n. 3 times -1 is -3, equals 5n plus 3 minus 2n. And that is called, that was on your quiz today, right? That first one is called the distributive property. And we learned that one the past 3 or 4 classes. Distributive property. So that one's old. The next thing we're going to do is this. We're going to take our 5n and our 2n, and we're going to do our combining like terms, our C. 5n minus 2n. Remember, if they're on the same side, this is the point where most of you struggle. When you get to this, you forget to combine your like terms. You start moving them. So 5n minus 2n is going to give me 3n plus 3. I'm going to just copy down my 6n minus 3 here. And I'm going to abbreviate this one today. Combine like terms. I'll write it out because you guys can abbreviate in your notes if you want. And Erin, do you remember the other word? Because I think it was you who asked me this one time. The other word that we use for combine like terms? Begins with an S. Very good, Jack. Simplify. So I could use that word simplify too. Whatever word you want, simplify or combine like, that looks like simplify. There we go. Simplify. There we go. All right. So now we're going to get the variable on one side. Now when I start moving things from one side to the other, we're going to start using our of equality things because we're doing them to both sides. So remember, this is a positive 3n. It's my smaller one. I'm going to move it over by minusing 3n to both sides. And again, that is called the subtraction property of equality. Every time I say of equality, I think of women getting the right to vote. I don't know why. We have equal rights. 6n minus 3n is 3n, good. Minus 3 equals 3. Now I'm going to add 3 to both sides. So 3n equals, what's 3 plus 3? 6. So again, what's this property called that I added 3 to both sides? This is so repetitive, I know. Good. Very good. Addition property of equality. And I'm just going to abbreviate it this time. And then we're going to, the last step is we are going to divide both sides by what? 3. And what's that property called, do you think? We're actually, what are we doing to both sides again? So it's the, very good, division property of equality. Or you could say dividing. Division property, as long as you put that of equality in there, you're fine. The game tonight is... Really? I thought it was Cortland. I think it's Cortland. Yes, Cortland, yeah. All right, so the answer there was n equals 2. Is that, everybody got that one? Okay. All right, next page. All right, again, this wants us to justify. There's only, this one's going to be easy. There's not a lot. It doesn't tell us to check this one, does it? I don't think so. Just...
Yeah, it says check.
Oh, then we have to check. All right, so this one we are going to check because we'll have a lot more room on this one. So let's write our check over here. All right. Let's solve it first and check it, and then we're going to write all our reasons, okay? So the first thing is we're going to add 8 to both sides, right? And a lot of you, when you see a fraction, all of a sudden you freeze and say, I don't know what to do. Just make believe it's just an x. If you thought it was just an x, you would just add 8 to both sides, right? So it's going to give me 13 equals x over 7. And then I'm going to do what? This is divide by 7. Multiply both sides by 7. And we're going to get x equals, what's 13 times 7? Do it in your calculators. 91. Good. So now we're going to check 91 to make sure that we got it right. I believe it is right, but... So when you check, you usually rewrite the original problem. And we plug our answer, 91, back in for x. So I have 5 equals 91 divided by 7 minus 8. Okay, someone do 91 divided by 7 in your calculator. What is it? 13? Yep. So we're going to get 5 equals 13 minus 8. And then we say 5 equals 5. And it checks. Okay? On your homework tonight, there will be 1 or 2 that have checks. And I believe on your next test, you got to read carefully because it does say that. A lot of kids miss it. I know. But and usually on the regions, if they will say it like this: solve, justify, check. So they make you check when you have to justify, basically. All right. So now we're going to justify each step. The first step is adding 8 to both sides. So what's that called? When I add, what property is that? Addition, property of equality. Good. Yep. Sure. So I added, and what was my next step? Well, what? Multiplication property of equality, right? I just multiplied. That was division. You're right, John. That was division. But then opposite division is multiply. So multiplication property of equality. And that's it. Those are only 2 steps on that one. All right. Addition property of equality, multiplication property of equality. So now we're going to get into the new ones that we're going to do, where we're going to, they won't have you justify these usually because they're the identities or the no solution ones. So they're not going to tell you on the regions that this one might be a no solution. You just have to recognize it. Again, if it's no solution, you will have like the letters will be gone. So the letters will cancel out. And you'll have like a number that's not equal to another number. Okay? So I'll show you here. We'll still do our DCV. There's nothing to distribute. So we're going to combine our like terms. Here I'm going to combine the m's. So I get 9m minus 4 on this side. 12m minus 3m is 9m plus 5. This is how you know when your letters cancel out, because they match on both sides. The M's, so when I go to move the M's, when I go to do I did my combine like terms, when I do my V part, my variable, and I try to minus 9M from both sides, well, when they're the same exact number, of course, they just disappear. They cancel out. So that's how I know this is not right. Letters just don't cancel out. I bring down my -4, and it says, and then I bring down my 5. Does -4 ever going to equal 5? No. So that's why there is no solution. So the next one is an example of what we call identity. Identity, your letters may cancel out or your numbers may cancel out. Identity means, just like we talked about the identity property, right? Identity means that both sides are the same. So when both sides are the same, there's nothing, you'll have everything's going to match. So everything will just eventually cancel out. All right, so I'm going to have 2a plus 3 on this side. I'm going to do this in my head. 1/2 of 6 is 3. When I distribute 1/2 times 4a, half of 4 is 2a. You see how they're just matching, but they're opposites? 2a plus 3 and 3a plus 2. Now, at this point, you could call it identity, but we're going to subtract 2a from both sides. There we go. Our letters are going to cancel out again. But I get 3 equals 3. So at any point, at this point, you could have said identity. Or down here, you could have said identity. You're going to get them, everything's going to match. So those are like little tricks they throw in there on the Regents. So sometimes when they tell you to solve, you can't solve. And I believe they won't tell you it may be no solution, it may be identity. I don't think they'll tell you that. All right, we got 2 more to practice. All right. 1/3 of 15. Can anybody do that in their head? 1/3 times 15c? Good. 5c. How about 1/3 of 21? How many times does 3 go into 21? 7 times. Good. So here I distributed, so that would be if we had to write the properties, which we don't, that would be the distribution property. The next thing, I'm going to combine on this side my c's, and I'm going to combine my numbers. So 10c minus 3c is 7c. 7 minus 14 is a -4. No, sorry, -7, not -14. So my numbers and my numbers match, but my letters don't match. So we'll see what happens here. I'm going to move my smaller c, which is 5c, and I'm going to get -7 equals 2c minus 7. So that would be the subtraction property of equality. Now I'm going to add 7 to both sides. What happens when I add 7 to both sides? This cancels out to become a? No. What happens to this? That becomes a 0 equals 2c. So is this going to be a no solution or an identity? No, because we've got a letter there. We're dividing both sides by 2 here. Can I divide 0 divided by 2? Is that possible? Do it in your calculator. I want everyone to do 0 divided by 2 and tell me if you can do it or not. You get 0. So can 0 be an answer? It can. 0, it can be an answer. But a lot of kids get confused when we teach them this. We're like, it's no solution. They mistakenly think a 0 is no solution. Then that's not the case. 0 can be an answer. The only time where it doesn't work in your calculator, if it was opposite, 2, you can't divide, you can't have 0 in your denominator, but you can have it in your numerator. So that's just the answer. I think you might have one of those like that on your homework. All right, I'm going to distribute first. 2 times 2b is 4b. 2 times 1 is 2. Let's see who can do 3/4 in their times 16. Can anybody distribute that for me? Does anyone know how to do fractions in their head? Go ahead, John. How do you do it? Did you do it in your head? Oh, okay. You can do it in your calculator. That's fine. But if you do it in your head, ready? Watch. 4 goes into 16 how many times? 4. 4 times 3 is 12. B. Let's do it over here. You can do it in your calculator, 3/4 times 20, or do this in your head. 4 goes into 20 how many times? 5 times 3 is 15. That's how you do it in your head. You take that denominator, divide it into that, and then multiply. Or just, like I said, do it in your calculator. It's fine. Now we're going to combine the b's on this side. We got 4b plus 4b, which gives me 8b plus 2. And then I have to move my b. I want to move my smaller b, which is going to be 8b. There's the subtraction property of equality if we wanted to write that. You do not like numbers? Is that what you said, Seth? All right. Now we're going to add 15 to both sides. And then I get 4b equals 17. And every time I teach this unit, people say, oh, well, that's not going to work because I get a decimal. Can I have a decimal answer? Yes, you can. I just don't want, that's why we give you these other examples, to show you that decimals are, what is it, Seth? 0.235? 4.25. There we go. You went the other way. All right, 4.25. So that is it. Okay? So for classwork, I have a little bit of classwork. We're not going to do IXL this time, I don't think.